Find the constants p and q such that the surfaces px square minus qyz equal to p plus 2 into x and 4yx square plus zq is equal to 4 are orthogonal at the point 1, minus 1, 2. So we have to prove that these two surfaces are orthogonal. It is given that the two surfaces are orthogonal at the point 1, minus 1, 2, and we have to find out the value of p and q. That means for which value of p and q these two surfaces are orthogonal at the point 1, minus 1 and 2. Suppose the two surfaces px square minus qyz minus p plus 2 into x equal to 0 is designated by phi, and another surface 4yx square plus zq is equal to 4. Suppose this is the surface psi. Suppose the surface phi is 1, equation 1, and the surface psi is given by equation 2. And it is given that the two surfaces phi and psi, these two surfaces are orthogonal. So for orthogonal surfaces, the dot product of the gradient of the surfaces is equal to 0 because the surfaces are scalar function, and gradient of phi, this is a vector, and gradient of psi, this is also a vector, and the dot product of two vectors will be equal to 0 if they are orthogonal because the angle between them is equal to 90 degree. So suppose this is equation number 3. So first we will find out the gradient of the surface phi, then we will find out the gradient of the surface psi, then we will put it in this equation 3. So gradient of the surface phi or the scalar function phi written as grad phi is also equal to del of phi, and this is your del operator, and del operator when operates on the scalar function, this will give you gradient. So if you find out the partial derivative of px square with respect to x, then that will be equal to 2px, and if you find out the partial derivative of p plus 2 into x, then that will be equal to minus p. Then with respect to y, if you find out the partial derivative with respect to y, then you have j cap minus q into z for this, because here you have no no y, here also you have no y, only you have to differentiate this one, so minus q into z. Similarly, partial derivative with respect to z, for z you have to only differentiate this one, that is minus q into y. So if you solve it, then we will find out the gradient of this scalar function phi at the point given point 1, minus 1, 2. That means you put the value of x equal to 1 and y equal to minus 1 and z equal to 2. If you put x equal to 1, this will be equal to if you put x equal to 1 here, 2p minus p, so it will be equal to p minus 2, and if you put the value of z is equal to 2 here, this will be equal to 2q. I have taken minus here this side. Then if you put the value of y equal to minus 1 here, this will be equal to minus again minus plus, so k cap into q. Suppose this is equation number 4. Similarly, you will find out the gradient of the scalar function psi or grad psi, that is equal to del of psi. This is your del operator, and this is your the function given function psi. So if you find out the partial derivative of this function with respect to x, then for this term it will be equal to 2x. 2x, so 2 into 4, 8. So 8y into x, I cap 8y into x. For j component, this will be equal to, if you find out partial derivative of this with respect to y, that will be equal to, you see j cap 4 into partial derivative with respect to y, this will be equal to 1, so 4 into x square. And for k cap, the partial derivative of z cube, that will be equal to 3z square, because here there is no z and this is a constant, so it will be equal to 0. So k cap 3z square. Now we find out the gradient of the scalar function psi at the point 1, -1, 2. So that will be equal to grad phi, that means equal to del of, grad psi, that means equal to del of psi. So if we put the value of x1 here, this will be equal to 1, and y value is equal to -1. So 1 minus 1, that will be equal to -1. So minus I cap 8 plus, if you put x value is equal to 1 here, this will be equal to j cap into 4 plus k cap. Put the value of z is equal to 2, 2 square is equal to 4, 4 into 3, 12. So k cap into 12. So this is equation number 5. Now we'll put the value of grad psi and grad phi in equation 3. So if you put the value of equation 4 and 5 in equation 3, then you will get the dot product of the gradient of the function, that is for 4, this is equal to I cap p minus 2 minus j cap 2q plus k cap into q. So I cap p minus 2 minus j cap 2 into q plus k into q, and from equation 5 you have minus I cap into 8 or I cap into -8, j cap into 4, then k cap into 12, and the dot product of these two vectors will be equal to 0. And if you take the dot product, only you have I cap dot I cap, that is equal to -8 into p minus 2, and then you have j cap dot j cap, that is equal to 1. So you multiply minus 2q into 4, and for k cap dot k cap is equal to 1, you will have q into 12. So q into 12, that will be equal to 0. So minus 8 into p plus minus again minus 8 into 2 16, so plus 16, 8 into 2 8, so minus 8q plus 12q will be equal to 0. So if you solve it, then that will be equal to, you see, if you solve it, you will get minus 8p, then minus 8p here, minus 8q plus 12q, so plus 4q, that will be equal to minus 16. So 2p minus q will be equal to 4. That is, suppose this is equation number 6. So to find the value of p and q, you put the given condition, that is the two functions are orthogonal at 1, -1, 2. So you put in equation 1, 1, -1, 2. So if you put in equation 1, the given condition, if you put in equation 1 here, you see, you put the value of, you see, x equal to 1, y equal to -1, and here there is no z. So if you put here, you will get p minus q into, you put the value of y equal to -1 and z is equal to 2. So that will be equal to 2q. Okay, minus p plus 2 into 1. So if you put here the value of 1 -1 2, then you will get this equation. You will get p minus q, you have put here the y value is equal to -1 and z value is equal to 2, minus p plus 2 is equal to 0. So p plus 2q, -1 into 2, again here a -1, so plus 2q minus p minus 2 is equal to 0. So p cancels, so 2q is equal to 2, so q is equal to 1. So you got the value of q. Now if you put the value of q in equation 6, then you will get the value of p. So if you put q is equal to 1 in equation 6, 2p will be equal to 5, so p will be equal to 5 by 2. So in this way you can find out the constants, value of the constant p and q so that the two given surfaces are orthogonal at the given point.